noticed that the earthquakes...
Hess's discovery that the seafloor was spreading rescued Alfred Wegener's idea of Pangea from obscurity. Now there was a geological mechanism to explain continental drift.
That's simple.
Once you hear it, it sounds great.
It does sound great.
By the 1960s, both ideas were synthesized into a single theory, the science of plate tectonics. A great discovery that revealed just how complex and dynamic our planet is. Several groups of scientists had concluded that not only is the Earth's crust moving, but the surface of the planet is broken into large, interconnected plates. These plates are constantly in motion, floating on a layer of molten rock in the Earth's mantle.
It seems fantastic. I mean, it seems just too crazy. How could the whole world be sliding around? I can see where people were skeptical.
That's right. That's right. But it's the rates your fingernails grow.
It's not very fast. I don't feel a thing.
That's right. Yeah. But cumulatively, it's huge. So here's the thing: is geologic timescales is what makes this so important. Because if you think of it over a year, you move a few centimeters. If you think over millions of years, you're moving kilometers. About 250 million years ago, all the plates were together in Pangea, and they've been moving apart, and they will come back together again.
Why do they move back together?
Because the Pacific Ocean right now has subduction all around it, and the plate is actually being consumed and recycled, where the Atlantic Ocean is spreading without much subduction. So the Atlantic Ocean is going to grow, the Pacific Ocean is going to close, and then we'll start getting closer to Asia and closing up the Pacific Ocean.
It's crazy.
It's pretty great. Crazy. And once you hear it, it's hard to imagine geologists not believing in it. So once the theory and the mechanism, that was the important contribution.
Because no one would believe it till they had it.
That's right. So the plates are spreading, they're not plowing.
The understanding of plate tectonics has given scientists new insights into the changing face of our planet. A dynamic example of some of those changes can be seen here on the California coastline, where two of the Earth's largest plates, the Pacific and the North American, collide.
There's a number of results, but one, we get volcanoes where the plates are subducted back into the Earth. These volcanoes happen because the plate that gets subducted releases water, and this water lowers the melting temperature of the overriding plate and makes it easier, and we get volcanism.
So that's where you get Mount Whitney, Mount Shasta.
Things like this, absolutely. The Andes are a perfect example of these type of volcanoes. Other places you get the mid-ocean ridges. You get pieces of the seafloor that are 1 to 2 kilometers higher than the surrounding seafloor. These are underwater volcanic chains that stretch the length of these ocean basins. Other places you get large strike-slip faults.
So what's a strike-slip fault?
A strike-slip is when the plates move by one another, okay? And they don't do it without kinks and twists, and so where the kinks and twists are, there can be places that lock.
Yeah.
And then they release, and they release quickly with a lot of energy or momentum.
Tipping over buildings and so on.
Causing a lot of shaking, yes.
But without earthquakes, you never would have found all this stuff, right?
Earthquakes are really important because they've allowed us to define the plate geometries. They've allowed us to define the boundaries.
So what about volcanoes?
Before volcanoes light off, a lot of times there's pre-eruption seismic activity.
Shaking.
Yes, yes. As the magma ascends to the surface, it causes stress, and the stress is released.
Do you see evidence of plate tectonics right here?
Yes. What we're looking at in the sea cliffs, these were deposited, these sediments were deposited about 500 meters below the sea level, and they've been uplifted. So here, we're looking at plate tectonics in our own backyard.
So far, we've explored what several great discoveries have revealed about what's happening inside the Earth. The next discoveries opened our eyes to what's happening above.